So we have to solve this radical equation and throw out any extraneous or extra or bad solutions. So think about what it means. It means what number plus 15 square root of minus 3 equals x. So if x is a whole number and not some weird number like irrational number or some odd fraction or something like that, if it's a whole number, we could probably guess, right? Because people that make these things up, they like perfect squares under here. So 1 would be a good thing to check. 1 plus 15 is 16. That's 4. Minus 3 is 1. Hey, look at that. Another one to check would be 10. 10 and 15 is 25. Square root of 25. 5 minus 3. But that doesn't work. But nobody wants to sit around and test out values to solve an equation, especially when there's an easy recipe to solve these. The recipe is isolate the radical, undo the radical by squaring if it's a square root, cubing if it's cube root, taking the cubed root if you have something cubed, taking the square root if you have something squared, and so on. In other words, undoing it with an inverse operation. So first things first, we got to isolate the square root. So that means add 3 to both sides. So, as promised, we're going to square both sides. And that leaves us with x plus 15 equals x plus 3 quantity squared. So this is where the trouble happens if we get extra solutions. When we square this, we're going to create problems where we may get a bad solution. So let's see what happens. We FOIL this out. I'm going to FOIL it in my head. X squared plus 3x is plus 6x plus 9. And on the left-hand side, we have x plus 15. Write it in standard form, meaning bring the x plus 15 over to the other side. Take away x from 6x, we get 5x. Take away 15 from 9, we get negative 6. So now you should be thinking, what two numbers multiply to negative 6 and add to 5? Well, positive 5. So the number with the greatest absolute value takes the sign of the middle term. So plus 6 minus 1. So our solutions are, our potential, our candidate solutions are negative 6 and x equals 1. So if we think back to our original equation, it was square root of x plus 15 minus 3 equals x. If we plug that 1 back in, we already know that that one works. That's square root of 16, which is 4 minus 3. Yes, that's equal to 1. Check. If we plug in negative 6, imagine plugging in negative 6. Everything I need is right behind the pause button in terms of tools. So let's plug in negative 6 now. So we're checking, is this a true statement? Well, you get 9 here. Square root of 9 is 3. 3 minus 3 is 0. Not equal to negative 6. So this solution, no good. Throw that one out. So the only solution is when x equals 1. So let's recap that. Started with the radical equation. Isolate the square root. Square the square root to undo it, to release it from the square root. That creates a square on the right-hand side, which we know a process for solving is write in standard form, factor if possible, use other methods if not. And then when we're working on these radical equations, you got to check your answers. Because when we squared that right-hand side over here, right here, we created an extra solution.